everybody. Today's lesson is all going to be to do with binary addition. I'm Josh. I was a computer science examiner for a lot of years. I was also a head of computer science and I taught in UK schools and I run a tutoring business. This series is all to do with giving you as little as possible to remember and still being able to access those top grades in GCSE computer science. These are all of the spec points, and as you can see, they're for all of the different examples, and they all have to cover going through binary addition. They also have to go through shifts. Now, I'll do an individual video for each specification, but as you can see, there's a little couple of extras that I've got to add in. So for Cambridge International, you've got to know about how to convert between positive and negative numbers. So I'll add that in on that one. OCR is pretty much just converting between binary numbers and doing shifts, so that's absolutely fine. AQA I need to add in at the end of this, how to add 3 binary numbers together, but we're just going to go through the basics to start with. Now, let's have a look at the rules for binary addition, and what I'd be doing for every single question, similar to the hexadecimal ones where I get you to write down A is 10, B is 11, and so on. These are the different rules for binary. Now, in binary addition, we cannot have a number greater than 1 because the numbers can either only be 0 and 1. So these are the rules. So we've got 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. And then this is where it gets a little bit confusing, and I'm going to show you with a few examples of what this means. 1 plus 1 is equal to 0, carry the 1. 1 plus 1 plus 1 is equal to 1, carry the 1. So write those down, and then let's have a little go at a question with this. So what we're going to do, get these rules, make sure that you write them at the top, just so that it gives you a quick reminder of what each of these things are. You are then going to start from the right-hand side, which is going to be 1 plus 0 is equal to, and if we check the rule, so 1 plus 0 is 1. So I'm just going to write that down there. 1 plus 1 is equal to 0, as we can see here, carry the 1, which I'm going to write up here. 1 plus 0 plus 0. This is the same as rule 3, so we're just going to write a 1 down here. 0 plus 1 is going to be 1. Now if we have a look, and just to prove that this does actually work, so if we do our little 1, 2, 4 and 8, that there, 1 plus 2, 3. 8 plus 2 is 10. 8 plus 4, 12. Add the 1, so then that's going to be 13. So we know that we've done that correctly there. But let's have a look at a slightly more complicated example. So this is where we've got 8 bits. So let's have a look at how we do this one. So starting from the right hand side, 0 plus 0, check our rule, 0. 1 plus 1, 0, carry the 1. Yeah, because it's just going to be activating that one. 1 plus 1 plus 0 is the same as rule 4, so 0, carry the 1. 1 plus 1 plus 1, that's the first time that we've seen rule 5 come in, so we put a 1 down here, put 1 up here. 1 plus 1 plus 1, 1 down here, carry the 1. 1 plus 0 is just the same as rule 3, 1. 0 plus 1, 1. 1 plus 0, 1. And we're done. If you did do the method of, so they don't, just a little side note, they don't like it if you do the method of convert it into a denary number, convert that one into a denary number, add them together, and then convert it back into it. They want to see that you've done it using binary addition rules, so make sure you do it that way. Final one, which I just want to go onto here, is 1 plus 1, because sometimes they're not going to give you a grid. So let's have a look at how we do it on this one. So 0, carry the 1. 1 plus 1, 0, carry the 1. 1 plus 0 plus 1, so 2 1s there, so 0, carry the 1. 1 plus 0 plus 0, 1. 1 plus 0, 1. 1 plus 1, 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1 plus 1 is 1, carry the 1. Now, something has happened here which is called an overflow error, which is something I want you to write down. They do sometimes follow on with the question. This is the next question that they would ask, which is, we've got too many bits, okay? The computer cannot make up more more memory to hold this. So this is what's called an overflow error, where we've got too many bits to use for our memory. So what happens is it gets forgotten, and this is what's called an overflow error. So the next part that we have to do is the data shifts, which is going to be to left shift and right shift. So let's have a look at how we do this. So we perform a left shift by moving all of the ones just one place to the left. So 1, 1, and then you just put the rest of the zeros in. 0, 0, 0. This number, 16 plus 8, is going to be 24. I then move this one here, 1, 1. Let's do it once more, just so that you can see the effect. So it's going to go there, and then just 2 zeros in here. And that is going to be 48. Now, if we look at the effect that this has, a left shift of 1 on 12 up at the top here is like times in by 2. The next one, if we did a 2 left shift, so if I moved it 2 places, we can see it's times in by 4. And if we moved it by 3, it would be times in by 8. The other way as well, so if we do right shifts, you can see if we did 48 and we moved it 1 place to the right, we've divided by 2. If we did a 2 shift, then we've divided by 4. And this is what you need to understand, is if we move it to the left, we're multiplying. If we're moving to the right, we're dividing. And what the common question that they might ask you is what effect, say, a 3 shift has or a 2 shift has. And as long as you remember, the first one is 2, the next one is 4, the one after that is 8, and it just keeps multiplying by 2, you'll be absolutely fine. So, for Cambridge International, you have to know how to convert between positive and negative numbers, and that is what's called performing 2's complement on the binary numbers. So the first step that we're going to do is, if I show you how to do it with minus 67 and minus 48, first thing, we just put them as a positive number. So 0, 1, 0, 0, 0, 0, 1, 1, because 64 plus 3 is 67. Now, what we do is we're going to go from right to left and find our first 1. Everything at this one and before it stays the same. So that's just going to be a 1, and then everything after it is flipped. So because that's a 1, that becomes a 0. That's a 0, so that becomes a 1, 1, 1, 1, 0, 1. Let's have a look at how to do it with 48. So 48 as a positive number. Step 1, 0, 0, 1, 1, 0, 0, 0, 0. That's 48 as a positive number. Now, same method, going right to left. Find our first 1. Everything at it and before it stays the same. 1, 0, 0, 0, 0. And then what we do is everything after it is flipped. 0, 1, 1. And then that's your negative number, and that's your negative number.